Hello everyone, I'm Arun here, going to talk about camera choices for vision application. So in this video, I'll talk about what mission vision is and then also talk about what are the different parameters which influence the camera we take for the mission vision application and then wrap up the entire session. So what is a mission vision? So basically mission vision is using vision for industrial applications, as in for defect detection or visual measurements or classifying what different part it is. So these are some of the applications of this vision system. But if we want to use it, there are some constraints which come along with it. We cannot use any camera off the shelf and then use it for our application because there are some constraints such as like measurement accuracy. Every part has its own accuracy in which we need to measure it, and then the area of the region of interest, like how big is the part and what needs to be there in that image, and also the camera location. And each of this I would go through in the coming slides and also explain how that influences the choice of the camera. For example, if we take an example of measuring a size of the gear. So a camera would take an image of the gear, which you're seeing now, but what makes up this image is nothing but if you take a small slice over here, that is composed of several pixels, and each grid is a pixel and it represents a unique data. And when it comes to measurement accuracy, a good rule of thumb is that if we want to measure something within a given tolerance limit, we use that tolerance limit and then we make sure that we have at least 10 pixels representing that tolerance unit. This is done so that the pixel accuracy is intact. So for example, if we have a tolerance of plus or minus 1 mm for measurement of this gear's diameter, then it would mean that 0.1 mm should be the size represented by 1 pixel, as in the spatial resolution, as in the 1 pixel would represent 0.1 mm on the part. And the next thing which would be crucial is that what are we going to actually measure? So in this case, I wanted to measure the size, the diameter of this gear. So if you want to measure the diameter, we need to have this entire gear in the field of view of the camera. So here you can see that this is the field of view, and this is the lens of the camera, and then this is the camera sensor. And you can see that from the field of view, it gets shrinked to the sensor size. But if this gear has to come on the image of this picture, this entire thing should be inside this field of view. For example, if you take the vertical height of this field of view, that should be equal to the diameter, assuming that this vertical height is the smallest. And we need to have the diameter fit inside this vertical height so that the entire gear is captured in that image. So if we do the math, say we have 100 millimeters of the diameter, and then we want to calculate what is the resolution of the camera we would need to get the 1 mm tolerance requirement. So from the tolerance requirement or the accuracy requirement, we get 0.1 mm is equal to 1 pixel. And then from the field of view requirement, we get that 100 millimeters is equal to 1000 pixels. So as in that this vertical field of view should be composed of 1000 pixels in the vertical direction. And then taking a square field of view, we would get 10 to the power 6, so squaring this value, and then we would derive at a 1 megapixel camera. So by this calculation, we would be able to narrow down what the resolution of the camera should be. So the next question would be like, what about the lensing? So if we take a situation, any situation, there is always some mechanical constraint. That is, the part is on a conveyor and the camera can be only mounted on a specific location on top of the conveyor, and this is restricted through some mechanical requirement. And so we have a given working height of which we need to start working off. So that's when we use this formula, which is nothing but basic trigonometry, where what you're saying is that this angle should be equal to this angle. And how do we do that? Is that this vertical height divided by the working distance must be equal to this vertical height of the sensor divided by the focal length. And that's how it's possible to have similar angles on both sides. And using this simple formula, we can derive the lens requirement based off the working height we have. So here the focal length of the lens would be derived from using the working distance, which is a constraint, and then the field of view height, which we derived from like the region of interest, and then the sensor height, which we chose previously. And through this way, we have gone through a systematic process of getting what the lens is for this vision application. So to sum up, you would basically start with what the tolerance requirement is, and then using that and the field of view, you would narrow down on your camera resolution. And the next thing would be to go about and figure out what the camera lensing should be. And that is figured out using the working distance and the formula to determine what the focal length of the lens is. So with those two in mind, we would be able to get what the what the resolution of the camera should be and the lens requirement so that we can get started on our mission vision application. Thank you, and follow me for more videos of these episodes.